Thanks for joining me today, Tsahi. Let's talk about TCP and WebRTC. Tell us, why do you hate TCP for real-time media? Why do you hate the internet?
I think TCP is great. It's just not the thing that you need for sending media in real time.
Okay.
Yeah.
Uh,
So the way it works and the way most of the things that we do on the internet work is that we send a request, we get a response. Either the request or the response are almost always sent over TCP. Ignore HTTP3 for now; it's unimportant. Okay. When you send something over TCP, you are guaranteed that it will reach the other side, or the connection will be lost and closed. Okay, so either what I'm sending you gets there, or there is no connection. That's a guarantee that you have. Now, how do you get such a guarantee? And the answer is by retransmissions. If I'm sending you a packet of data, on your end, you're going to acknowledge that packet. If you don't, I need to retransmit it, okay, until you receive it, or until we both decide that, well, this doesn't work, let's close the connection. Now, what's the problem with that? Let's say that what I'm sending you is my voice in real time, which is what we do in WebRTC. Now, when I'm sending the data, you're not going to receive it because packet loss. So, request for a retransmission. I try to retransmit it. You don't receive it. I try to retransmit it again, multiple times until I succeed. Now, guess what? It's now too late to actually use that packet because the time has passed for you to use it and decode it. And that's the problem. Okay, in WebRTC, we have mechanisms inside WebRTC to decide when to retransmit, when to decide to drop the packet and move on, when to use forward error correction, or when to just get a new keyframe in video. All of these mechanisms are there because we know that if something is lost, it might be lost forever, and there is no need for us to try to retransmit it. So that's the beginning of it. Mm-hmm. Now, let's say that I'm using TCP on top of WebRTC. I've actually sent you the data that I want, but you're not receiving it. Eventually you will. What does that mean? That I'm going to use bandwidth to send data that you're not going to be able to use. You know that you're not going to use it. I know that you're not going to use it at some level, okay? But I'm still going to invest the time to send it to you because it is over TCP. Why? I don't have any control over that retransmission mechanism. And that's where we're losing a lot of the control. Now, when do you have packet losses? When things are bad in the network. What does that might mean? That there is congestion. So I don't have enough bandwidth to begin with, but I'm using bandwidth to send retransmissions that are not needed. And I'm inside this loop of doing things that are not needed that exasperate the problem. They make it worse than it already is. Mm-hmm. Because we're using TCP and TCP is so reliable, we don't want that. So instead of being able, for example, to drop bitrate really, really quickly for video, because of that big frame that we're trying to send over HD or whatever, I'm going to finish sending that frame that you're not going to use because it's too late, before I start reducing the bitrate to where I can actually use it to send lower bitrate of video. Okay? So what happens with TCP is that it ruins our ability to manage the bandwidth dynamically, really, really quickly, and we end up wasting resources of the network when we most need them. And that's why I TCP for WebRTC.
Yeah, so we get into this bad loop where we would prefer, with a video call, we would prefer to have lower latency, even if it means a little bit less quality or occasional dropped packets. That's more important to us.
Yes.
And as opposed to other situations, like maybe in signaling, where it's often use something like WebSockets that's based on TCP because you want to guarantee delivery of packets, right? That's more important in that scenario.
Yes, I'm fine if the answer button that I pressed will take 100, 200 milliseconds more because of TCP retransmissions.
Right. We're not going to notice that.
Yes, even half a second would be better than nothing at all.
Yeah. So if someone blocks UDP traffic in their firewall, for example, and they're trying to do WebRTC calls over it, one of the things we might notice is higher latency in our call. In our conversation, which might lead to us talking over each other, right? What other things might you notice if someone has done that to your network and you're having
So
WebRTC problems?
let's start with this. If the network is good, you won't see a problem. So you'll say it's actually stupid. He said TCP is no good, but it works well for me. Well, it does, but the challenge won't start when TCP is there. It will start when you have packet losses and TCP running together. That's where things will get screwy. And for example, if you look at the statistics, you won't see packet losses like running there low. There will just be a burst of packet loss because, well, that's life. There is reliability, but at some point you simply lose these packets or discard them or do something bad with them. So the whole statistics will look differently than they usually do. So that's one thing that you'll notice. The other thing is, well, I would say this: if you are in a contact center, what I've noticed along the years, especially with the customers that we have in TestRTC, they end up coming and saying, well, we don't use TCP. We don't use turnover TCP. No, it's not there. We use UDP or nothing at all. Why? Because we're a call center. The agents, this is their work. They're employees. We expect them to have a network that supports UDP or they can't work here. They need to solve that problem.
Right.
Now, you won't see that in video meetings or in UCAS, Unified Communications, because I'm not sure the people are, where they are, what they're doing. It's not call center agents. So it's more of a best effort kind of a solution. And there, yes, we're going to use turn TCP and turn TLS because the alternative is nothing at all. So you can have a bad call or no call. Choose. Call centers would choose no call. Unified Communications would choose bad call, usually. Now, what would I do in such a case? If I were the engineer, for example, and I know that this call is a call over TCP, I would be more aggressive in bandwidth estimation in terms of dropping it down and using lower bit rates than I would with UDP. So if I say, I'm going for 2 megabits per second in my calls for UDP, I would say 1.5 for TCP. Why? Just because I want to be in a safer position. So I'll try to use less than what the bandwidth estimation would even give me. Because again, if I hit these issues of packet losses, they're going to kill me, and I'm going to find that a lot later than I would with UDP.
So it might affect how we configure, say, simulcast in our application, as we talked about last month, or how quickly we just turn off video entirely, if that's an option in our application, and try to go with an audio-only call. So, so lots of factors here, and this is a matter of
other things.
Go ahead.
Would you ask for a NAC message or an RTX message over TCP? No. Because TCP does that for me. So why would I do that? Would I enable FEC for the error correction? No, because I've got retransmission automated by this. So there are also mechanisms that you would do over UDP to improve video quality that you should disable if you end up on TCP, because it's not that they're not good for you, they're bad for you. Okay, so you need to see exactly what tools you're using in UDP and decide if they make sense over TCP when you start optimizing these types of calls.
Absolutely. Makes sense. All right. So as is often the case, how we're going to architect our application and balance these trade-offs depends a bit on our use case, on the types of users, the networks that they're operating on. So as always, a lot to consider here. So thanks for sharing your insights with us today, Tsahi. As always, to learn more about Tsahi's work, you can check out bloggeek.me. And to learn more about future episodes of WebRTC Live, check us out at webrtc.ventures. Thanks a lot, Tsahi.
Thank you, Arin.